Assalamualaikum warahmatullahi wabarakatuh. My name is Narafika Mutasim. Today, me and my friends from Group 5 will explain about the system of linear equations using LU decomposition. And to solve the system of linear equation using LU decomposition, we have two ways to solve it. The first one is manual by hand, and the second one is using programming software, Mathematica. So the first one I will explain to solve the LU decomposition by hand. And as we can see here, there is a problem to solve the system of linear equation using LU decomposition. And from these problems, we will get the matrix A, which is 3 by 3 matrix. And the NP is equal to 1, 2, and 3. Next, from this matrix, we need to set the vector NP equal to 1, 2, and 3. And this vector is used to record which rows are interchanged. So the NP is 1, 2, 3 is represent the rows. So 1 for row 1, 2 for row 2, and 3 for row 3. And the first step we need to do is factoring. We need to search the first column for the element of largest magnitude. So from this matrix, we need to check the first column and search which is the largest magnitude in first column. And since 4 is the largest element, nothing changed. The NP remain the same, that is NP equal to 1, 2, and 3. So if 4 in the second row, so we need to interchange the row. And the NP will be 2, 1, and 3. But for this matrix, since 4 is the largest element, since 4 is the largest magnitude, so there is no need to swapping the rows. And the NP will remain the same, which is 1, 2, and 3. Next, we need to perform the elementary row operation, which is we need to make A21 and A31 is equal to 0. So to perform elementary row operation for row 2, we need to do row 2 minus 1 over 2 row 1, and we will get the new row 2. So the new row 2, there will be A21 will be equal to 0. And the multiplier for M21 is 1 over 2. So this is the multiplier for M21. And the next one we need to make A31 is equal to 0. So we need to perform the elementary operation for row 3, which is row 3 minus 1 over 4 row 1, and we will get the new row 3. So from the new row 3, we will get A31 equal to 0. And the multiplier for M31 is 1 over 4. So this is the multiplier for M31. Next, from the multiplier that we get, we need to insert the multiplier to the matrix. From this matrix, this 0, we will insert the multiplier M21 and M31. So from this matrix, we will get a new matrix after we insert the multiplier, which is right here. This is the difference from the previous matrix. And then we're done with the first column. Next, we move to second column. We need to search the second column of matrix A for the largest magnitude. So from matrix A, the second column, we can see here 5 is the largest magnitude in this second column. And since 5 is the largest magnitude, no swapping was needed. Then NP remains the same, that is NP equal to 1, 2, and 3. If 5 is in the row 1, so we need to swap the row. But since 5 is already in the second row, there is no need to swap the row. And the NP remains the same, 1, 2, and 3. Next, we need to make A32 is equal to 0. So we need to perform the elementary rule for row 3. Row 3 minus 9 over 22 row 2, and we will get the new row 3. In the new row 3, the A32 is equal to 0. And same like before, the multiplier for M32 is 9 over 2. Next, we need to define the upper triangular U and lower triangular L matrices. The L and U matrices are given by, so this is the new matrix. This is the matrix for lower triangular, and this is the upper triangular matrix. From this matrix, we will get the lower triangular matrix and the upper triangular matrix.
Hello, my name is Nur Fatiha binti Muhammad Fadli, and I will continue the explanation of LU decomposition by hand. Okay, for the step 2, we need to use forward substitution. By using forward substitution, solve for Ly equal to PB. Since B equal to 8, 3, 11 and MP equal to 1, 2, 3, P, the permutation matrix is given by P equal to 3 by 3 matrices, which is 1, 0, 0, 0, 1, 0 and 0, 0, 1. Multiplying with PB gives that the matrix for P multiply with the matrix of B, we can get the value of PB, which is 8, 3 and 11. Ly equal to PB. So this is the matrices of lower triangular matrix. Multiply with matrix Y, which is Y1, Y2 and Y3 equal to the matrix we have the matrix PB, 8, 3 and 11. From the matrices Ly equal to matrices PB, we expand until it becomes an equation, which is from the given matrix, the equations are y1 equal to 8, 1 over 2 y1 plus y2 equal to 3, 1 over 4 y1 plus 9 over 22 y2 plus y3 equal to 11. Then we must solve to get the value of y1, y2 and y3. As we can see, y1 there is given y1 equal to 8. So y1 equal to 8. Then to get the value of y2, we must substitute the value of y1 into equation 2, and then we can get the value of y2, which is negative 1. As for y3, the value of y1 and y2 that we have obtained before, we must substitute into the equation 3, and we can get the value of y3 equal to 207 over 22. Okay, the last step for LU decomposition is by using back substitution. From back substitution, we need to solve Ux equal to y. The upper triangular matrices that we've obtained before, we must multiply with the matrix of x, which is x1, x2 and x3, and then equal to the value of y1, y2 and y3. Okay, from the third equation, from this matrix, we must turn it into equation, and then from the third equation, we can simply get the value of x3, which is 69 over 22 multiplied with x3 equal to 207 over 22. So we can get the value of x3 equal to 3. Okay, from the second equation, 11 over 2 x2 plus 3 over 2 x3 equal to negative 1. So we substitute the value of x3 that we have obtained, and eventually we can get the value of x2, which is negative 1. As we have get the value of x2 and x3, we can simply get the value of x1. From the first equation, we substitute the value of x2 and x3 into the first equation, and we can get the value of x1, which is equal to 1. Thus, the solution to this system of linear equation is x equal to 1, negative 1, 3, t.
Assalamualaikum warahmatullahi wabarakatuh. My name is Tuan Akila binti Cik Noh. So now I'm going to explain how to solve the system of linear equation using LU decomposition by Mathematica. So first we use the command above to get matrix M, P and condition number. Matrix M is the LU matrix. So this M3 here defines the 3 by 3 matrix. And this matrix, we call it as matrix A. This is matrix A. So press Shift plus Enter to run the command and the output displayed as below. So from the command previously, we will get M, which is the LU matrix, P and condition number. So know that this one is the M. Because matrix A is in 3 by 3 matrix, so matrix M will also be in 3 by 3 matrix. So this is our matrix M. This is the first row, second row, and the third row. This is our P, and this is the condition number. For next step, we just want to use the matrix M. For the P and condition number, we are not going to look at it. So just ignore the P and condition number. So next, to show the M matrix in matrix form, we use the command as above. So this is our list of matrix M / matrix form. Run the command and the output displayed as below. So this is the matrix M in matrix form. So from the matrix M, we're going to split it into lower matrix and upper matrix. Next is the command to get the lower and upper matrix. So L is equals to lower triangularized M-1 plus identity matrix. M is the command to get lower triangularized matrix. I will explain it later. What does it mean by lower triangularized M-1 and plus identity matrix? For the upper triangularized, we use U. U is equals to upper triangularized M is the command to get the upper triangularized matrix of M. Lower triangularized M-1 is the command to get the strictly lower triangularized matrix of M. The strictly lower triangularized means that the diagonals are zeros. So we have 0, 0, 0, and since it is lower, we have to fill in some numbers at the lower part. So this 0.5, 0.25 and 0.4, etc. This is from the matrix of M. And the upper part will be filled in zeros. Identity matrix M is a square matrix in which all the elements of principal diagonals are 1 and all other elements are zeros. This is the basic of identity matrix. So we know that the elements of the diagonals are 1 and all other elements are zeros. So run the command and the output displayed as below. By the combination of lower triangularized M-1 and identity matrix, we will get this lower triangularized matrix. So we can see here the diagonals are 1 and the lower part has the elements from the matrix of M. And the second output is from the second command, which is the upper part. So this is the upper matrix of M. The diagonals are from matrix of M, and also the elements for the upper is also from matrix of M. The lower part must be zeros because this is upper matrix.
Assalamualaikum. My name is Saidatina binti Muhammad Azam with number matrix D201820863338. So, in this part, we will learn about LU decomposition by Mathematica. So, in previous part, you had learned about how to find the lower triangular matrix and upper triangular matrix. So, we can find the matrix A using the product of upper and lower triangular matrix. So first step, the input is L.U/matrix form. So in this case, I put it matrix form means I want the final answer in the matrix form. Okay, next we will run the command and the output display as below. So the output will give us the matrix of a input LUD equal to LU decomposition M3 4 2 1 1 5 2 1 2 4. Okay, next LU back substitution bracket LUD 8 3 11. Okay, in this case 8 3 11 is matrix B. Next, three component written by LUD position, which is matrix M, LUP, and condition number. 8 3 11 is matrix B. The command above can be used to get the solution using LU decomposition automatically. Run the command and output display as below. For -1, 1, 0.5.5, 1.5, 0.25, 0.409091, 3.13636. So this is the MLU. So 1, 2, 3 is P, 4.17391 is condition number. 1, comma, -1, 3 is the value of XYZ using the command LU back substitution LUDB. So that's all from us. Thank you.